Entering into CAE sector is a dream for many mechanical, civil and aeronautical engineers. CAE stands for Computer Aided Engineering. If a person has to enter into CAE sector as a fresher, he has to undergo technical written test, aptitude test, followed by HR interview. Doing internship in any CAE company will be added advantage, or doing academic project using any CAE tool will be added advantage. Nowadays, many CAE companies in India are conducting tool tests on any pre-processing tool such as Hypermesh, ANSA or ANSYS. Now we will discuss about the sample interview questions in LS Dyna. You may expect the following questions when you are attending interview in LS Dyna with 1 to 2 years of experience in any pre-processing tool such as Hypermesh or ANSA. What are the different steps involved in FEM? What is LS Dyna and what are its characteristics? What is time step? How time step is calculated for beam, shell and solid elements? What is active safety and passive safety? Name some examples for the both. What is the difference between EL form 1, EL form 2 and EL form 16 for shell element? What is the difference between static, quasi-static and dynamic? What is the difference between implicit and explicit? What is the purpose of contact in LS Dyna? What is hourglassing? Explain in detail. What is the difference between SMP and MPP? What are sense switches? Explain in detail. Explain about different materials in LS Dyna. Explain about preparation of metal card for LS Dyna. Which EL form is preferable for tria, quad, tetra, hexa, penta, beam and spot weld? Finite element analysis comprises of pre-processing, solving and post-processing phases. Discretizing the part, that is meshing the components, assigning thickness, materials, loads, boundary conditions, removing intersections, penetrations, screw connections, spot welds involves in pre-processing phase. Hypermesh, ANSA, ANSYS, LS pre-post are the best pre-processing tools. The second phase in finite element analysis is solving. The operations in this phase are performed by the FEA software. The FEA program remembers the nodes in the mesh to minimize computational resources by minimizing the size of the global stiffness matrix. It generates a stiffness matrix for each element and assembles the elements together so that the continuity is maintained to form the global or structural matrix. Based upon the load vector, the software generates the external loads and applies displacement boundary conditions. Then the computer solves the massive matrix equation for the displacement vector or whatever is dependent variable in the problem. The constraint forces are also determined. The best solvers which are available in the market are LS Dyna, Radius, Abacus, Nastron, Pamcrash and Actron. The final phase in finite element analysis is post-processing. After completion of the solving, any solver will give some output files. Post-processing begins with a thorough check for problems that may have occurred during solving. Once the solution is verified to be free of numerical problems, the quantities of interest such as stresses, effective plastic strains or permanent deformations, and reaction forces has to be checked. The best post-processing tools in the market nowadays are Hyperview and LS Prepost. LS Dyna is an explicit finite element program. Explicit refers to the time integration. Central difference scheme is used for explicit time integration. LS Dyna is developed by LSTC, Livermore Software Technology Corporation. LS Dyna is a pure solver, so we have to give input file in specific format. Input file is generated using a preprocessor, for example, Hypermesh, LS Prepost, ANSYS or ANSA. Coming to the characteristics of LS Dyna, it has a wide choice of materials, large element library, contact algorithm. Wide choice of materials such as plastics with kinematic and isotropic hardening, strain rate dependency, temperature dependency, then foam, composite material, rubber, viscous, fluid. We can create our own materials by using Fortran interface. Then, large element library. LSDN is a hub for different element formulations. Simple and fast elements for standard applications are available in LS Dyna. Higher order elements are also available but costly. Costly in the sense it will take more time for solving. Then next, to detect the bodies during simulation, we have to specify contact. The contact algorithm prevents the penetration of nodes into element segments. Contact algorithms such as with friction, contact of deformable with rigid bodies in any combination, single surface contact, contact with analytical surfaces, contact rigid body and rigid body. The minimum time taken for the sound wave to travel from one side to other side of the element is nothing but the time step, where delta t is equals to L by C. L stands for characteristic length of the element and C stands for speed of the sound. As the element length is directly proportional to the time step, if element length in the model is small, time step will be small. If time step is small, it will take more time to solve the problem. Then speed of sound depends on element topology and the material properties. For solid elements, speed of sound C is equals to under root of E into 1 minus nu by rho into 1 plus nu into 1 minus 2 nu. For shell elements, C is equals to under root of E by rho into 1 minus nu square. For beam, C is equals to under root of E by rho, where E is the Young's modulus, rho is the density, and nu is the Poisson's ratio. If you observe, I have taken delta t is equals to zero point 0.9 times L by C, where zero point 0.9 is nothing but the time step scaling factor. As engineers, we have to be on safer side. So I have taken zero point 0.9 as TSS-FAC. If we are using higher explosives, we can put this value to 0.67. TSS-FAC is available in star control time step.